For decades, the laws of physics have defined the limits of semiconductor technology. Every nanometer pushed, every transistor miniaturized, was a testament to human ingenuity against fundamental barriers. We thought we knew the ultimate frontier. We thought we understood the absolute edge of what was technologically possible. But what if one nation just broke it? What if they just shattered the very rules governing the microchip industry, not by inches, but by light years? A whisper has turned into a roar across the global tech landscape. China claims a 1-nanometer chip. If true, this isn't just an advancement, it's a technological earthquake, a redefinition of Moore's law, and a direct challenge to the very foundation of modern electronics manufacturing. But did they truly do the unthinkable? Did China's 1-nanometer chip just break physics? Or is this the greatest technological deception of our time? The answer will redefine the future of digital innovation. Welcome back to Revo Now, your essential guide to the most disruptive technologies and profound shifts in the innovation landscape. Today, we're dissecting a claim so audacious, it's sending shockwaves from Silicon Valley to Taipei and beyond. Before we unravel this mind-bending mystery, if you're as fascinated by the absolute cutting edge of microchip development and the future of computing power as we are, do us a huge favor. Smash that like button right now. Your likes are crucial for helping us get this critical information past the algorithms. Share this video with anyone who needs to understand the true state of the semiconductor race and what it means for global power. And most importantly, subscribe to Revo Now and hit that notification bell so you don't miss our next deep dive into the most pivotal moments in tech advancement. Your support directly fuels our mission to bring you the unfiltered truth about emerging tech and the future of innovation. For years, the semiconductor industry has operated under the shadow of Moore's law, the observation that the number of transistors on a microchip doubles roughly every 2 years. This relentless march of miniaturization has driven every leap in computing power, from your smartphone to AI data centers. The current cutting edge, achievable by only a handful of elite manufacturers like TSMC and Samsung, is 3 nanometers, NMM, with 2-nanometer chips on the horizon for late 2025 or 2026. These are dimensions so tiny, we're talking about structures only a few dozen atoms wide. But a bombshell dropped. Reports emerged from China hinting at breakthroughs that would allow them to produce a 1-nanometer process node. Let that sink in. 1 nanometer. To put that into perspective, a single strand of DNA is about 2.5 nanometers wide. At 1 nanometer, you're almost talking about manipulating individual atoms. This isn't just an incremental improvement, it's a quantum leap, theoretically pushing the boundaries of silicon-based transistors to their absolute physical limits. The very laws of quantum mechanics become a massive hurdle at this scale. When you shrink components to just a few atoms, electrons can tunnel through barriers they shouldn't be able to, leading to leaks, instability, and massive power consumption. Overcoming these quantum effects requires entirely new materials, revolutionary fabrication techniques, and unprecedented control at the atomic level. This is why the global semiconductor roadmap has always viewed 1 nanometer as either decades away or requiring a complete paradigm shift away from traditional silicon. So, if China did achieve this, how could they possibly have done it? The global chip industry is currently reliant on extreme ultraviolet EUV lithography machines, primarily from ASML in the Netherlands, to print features at 3 nanometer and beyond. China faces significant restrictions on acquiring these cutting-edge machines due to export controls aimed at limiting their advanced chip manufacturing capabilities. One theory suggests they might have achieved this through incredibly sophisticated multi-patterning techniques with older deep ultraviolet DUV lithography tools. This involves repeatedly printing patterns to effectively create finer features, but it's incredibly complex, expensive, and generally not considered viable for mass production at such minuscule scales. Another, more speculative possibility involves breakthroughs in novel materials science, perhaps using 2D materials like graphene or transition metal dichalcogenides to create ultra-thin channels that mitigate quantum tunneling. Or could it be a completely unannounced radical new form of transistor architecture or quantum computing adjacent technology that bypasses traditional scaling limits altogether? The sheer secrecy surrounding this alleged breakthrough, combined with the extreme technical hurdles, naturally fuels suspicion. Is this a true scientific marvel, a testament to unprecedented R&D investment and engineering prowess? Or is it a strategic announcement, a geopolitical statement designed to disrupt the global technology narrative and project an image of technological self-sufficiency in the face of sanctions and trade restrictions? The absence of independent, verifiable proof is the key here. The implications of a genuine 1-nanometer chip are not just technical, they are deeply geopolitical and economic. The semiconductor supply chain is arguably the most critical and complex in the world. Dominance in advanced chip manufacturing translates directly to leadership in AI, quantum computing, military technology, telecommunications, and virtually every sector of the digital economy. If China truly possesses this capability, it would fundamentally alter the global tech balance of power. It would render many existing export controls obsolete overnight and potentially accelerate their progress in areas like hypersonic weapons, advanced surveillance systems, and next-generation supercomputing. It would mean genuine technological independence from the West, a long-stated goal of Beijing. This isn't just about a faster phone. It's about who controls the core building blocks of the future industrial revolution. It's about national security and economic supremacy. The stakes literally could not be higher. So where does the consensus currently fall on this mind-boggling claim? Most semiconductor analysts and industry experts are highly skeptical of a full production-ready 1-nanometer chip from China at this moment. The consensus points to several possibilities. 1. It could be a laboratory breakthrough, a proof of concept in a controlled environment, far from mass production. Achieving something in a lab is vastly different from scaling it to millions of chips. 2. It could be a strategic leak or disinformation campaign designed to create a psychological impact, to sow doubt among rivals, and to project an image of unstoppable progress. This is a common tactic in geopolitical tech warfare. 3. There might be a definitional discrepancy. What China refers to as 1 nanometer might not align with the industry standard definition of a process node, which often uses node names that are more marketing terms than strict physical dimensions at the cutting edge. They might be referring to a specific feature length, not the overall node designation. The biggest hurdle for independent verification remains China's relative opacity and the lack of traditional industry channels for confirming such claims. Without independent analysis of physical chips produced in volume, any claims, no matter how sensational, remain unverified. Even if the 1-nanometer chip claim is pure hyperbole, it's crucial not to dismiss China's semiconductor ambitions as entirely smoke and mirrors. Their progress in areas like mature node chip manufacturing, e.g. 14-nanometer, 12-nanometer, has been significant. Companies like SMIC have demonstrated capabilities at 5-nanometer, which, while not leading edge, is still highly advanced for many applications, including some AI accelerators and consumer electronics. They are pouring trillions into domestic chip production, R&D, and talent development. The long-term goal isn't just to catch up at the very bleeding edge, but to build a resilient, self-sufficient semiconductor supply chain within China. This involves everything from EDA software, electronic design automation, to wafer fabrication equipment, to advanced packaging technologies, and materials science. So, while the 1-nanometer claim may remain unproven, the underlying ambition and the undeniable, albeit slower, progress in building a domestic chip ecosystem are very real. The global semiconductor industry will never be the same, regardless of whether that 1-nanometer claim holds true. The race for chip supremacy is escalating, and the stakes are higher than ever. So, what's your take on China's 1-nanometer chip claim? Do you believe it's a genuine breakthrough that breaks physics, or a strategic move in the ongoing tech war? The world of advanced semiconductors is complex, and the information is often shrouded in secrecy and national interest. Your perspective is incredibly valuable here. Let us know what you think in the comments below. This conversation about chip technology and global innovation is far from over. What other technological mysteries or future tech trends should we explore next on Revo Now? Are you curious about the next generation of AI hardware, the race for quantum computing dominance, or the future of sustainable tech? Tell us what ignites your curiosity. And if this deep dive into the semiconductor industry captivated you, remember to like, share, and subscribe to Revo Now for more exclusive content and in-depth analysis of the future of technology. Thanks for watching, and we'll see you at the absolute cutting edge. This is Revo Now signing off.